Hello friends, welcome back to our channel. So today we'll see one more concept in our machine learning, that is distance measures. So in our previous session we have discussed about the proximity measures, so which are being used to find the similarity between two objects or how far apart of one object with another object. So in the today's session we'll see what are the distance measures. So what are the formulas for a distance measures, common distance measures. So let's start the session. Distance measures. So here the name itself indicates a measure means it is a mathematical techniques. So there will be some mathematical formulas. So these are mathematical techniques. Why we are using? Used to find the similarity between the objects or points. Find the similarity between objects or points. Similarity or how far one object with another object. So here a common distance measures. So we'll see a common distance measures. What are the common distance measures? There are a lot of distance measures. So we'll see a common distance measures. So the first one is a Euclidean distance. So this is a common distance measure in order to find the distance between two different data points. Okay, so it will take a numerical value. So all the numerical values only, and the distance measure d, the formula is so square root of sigma xi minus yi whole square. So this is the distance measure formula for the Euclidean distance. Okay, and this can be used in a KNN algorithm or a k-means algorithms. Okay, so let us take an example. Let us take a point as 2, 3 and another point as 5, 7. Okay, now the Euclidean distance is equal to square root of 2 minus 5 whole square plus 3 minus 7 whole square. So you can see this is a x and this is a y. So xi minus yi whole square, that means sigma, it's a sum. So here 2 minus 5, okay, xi means 2 and this one, right, and 3 minus 7, x1 x2 y1 y2. Okay, the next, here you can see the formula. So 3 square, it is a 9 plus, and here it is a 4 16, it is a 16, it is a 25, right? So which is equal to 5. So 5 is the distance measure between these 2 points. So you can if you are having a confusion, this is a normal distance measure, so we can write it as so xi minus xj whole square plus yi minus yj whole square. Simply we can write it. So normal distance formula. This is a normal distance formula, right? So between 2 points we can find this distance, x2 minus x1 whole square plus y2 minus y1 whole square. The same thing we have applied and we got a distance as a 5. So which is the distance between two different data points. We can say it as a data points. And this Euclidean distance will be used in KNN algorithms or k-means algorithms. This is the first one. Okay, first distance measure is a common distance measure, that is a Euclidean distance. Next, the second one is a Manhattan distance. Manhattan Manhattan distance. So here also it will be taking the numerical values, only the numerical values. Okay, and the formula for this one is D is equal to simply we can write sigma xi minus yi. Okay, sigma xi minus yi. So mod. So if you take the previous example a 2 comma 3 and a b 5 comma 7, so simply we can say it as sigma or D is equal to, so 2 minus 5 plus 3 minus 7. Okay, so this is the thing, 2 minus 5 mod, and here also it is a mod 3 minus 7, which is 3 plus, which is a 4, the distance is 7. So the Manhattan distance is to find the distance between two different data points, and this is particularly it is the distance measure which can be used to calculate the distance between moving only either horizontal or vertical, either horizontal or vertical. There is no diagonal, right? Either horizontal. If the objects are moving either horizontal or vertical, then only we can use this Manhattan distance. And the main applications where we can use this Manhattan distance is, so grid path. If you are having any grid path problems, then we can use this Manhattan distance. So grid path means only there will be horizontal lines and vertical lines, right? So in this kind of problems we'll be using this Manhattan distance. Next, the third one, we'll take the points here. Always we need not erase this one. So b is equal to 5 comma 7, right? Next, the third one, Minkowski distance. Minkowski distance. So this is a general distance measure. It's a generic distance measure. Okay, so we'll see the formula, generic distance measure. So by using the same generic distance formula, we can also use the Manhattan distance as well as the Euclidean distance. And next next one, see the distance measure D is equal to, so sigma xi minus yi whole power p and whole power 1 by p. And here if p is equal to 1, if p is equal to 1, that becomes Manhattan distance, and if p is equal to 2, that will be the Euclidean distance. So you can apply the formula. So if it is 1, so then it will be xi minus yi, and here it is also 1, and if it is 2, it will be square and it will be root. So Euclidean distance, we'll be getting the Euclidean distance formula. So this is a generic distance measure. Next, the next kind of thing, the fourth, Chebyshev distance. Chebyshev distance. Chebyshev distance is to find the maximum difference. It is used to find the maximum difference between the two data points. The formula will be D is equal to maximum of xi minus yi, right? So here example we can take this one. So D is equal to a maximum of sigma, you can write. So 2 minus 5 comma 3 minus 7. So which will be a maximum of 3 and a 4. So the distance measure is here 4 in this example. So that is a Chebyshev distance measure. So where it can be used means it will be used in chessboard movement problems. Chessboard movement. chessboard movement problems. So Chebyshev distance. Next, the next one is cosine distance. And previously Chebyshev distance will also be working on the numerical values, and this cosine distance will be working on vectors, different vectors. So the formula will be cos theta is equal to vector A vector B by mod A mod B. So this will be used for vectors, particularly for the vector applications. Okay, and the applications where we can use this cosine distance, text mining, particularly text mining, that means the comparing of documents. So application is a text mining. In the text mining it will be used. Similarly in search engines, also it will be used, this particular cosine distance, right? The next one, all we know this, the next distance, that is a Hamming distance. So we know the use of a Hamming distance. So the input for this Hamming distance is a binary values, binary strings or binary bits or strings. So what happens here, it finds the differences in position of bits, right? So for example, let us take 10101 and the another one is 110101. So here you can see the difference, both are equal, both are difference, both are different, both are equal, and both are equal. So how many differences are there? Only 2 bits are differences, so the difference will be 2. So here the input is of binary numbers or strings. Okay, and where it will be used means it will be used for error detection. So we have studied in our computer networks and so on. So error detection, and also some kind of classifications, binary classification, these are being used, binary classification, right? So this Hamming distance will find the difference between the position of the bits, right? Next, the next one, Mahalanobis distance. So here it is a generic, this is also a generic distance measure. So here there is no formula. So this will be measured by considering correlation between variables, correlation between different variables. So by considering this correlation between variables, it will be finding this measure. And where we can use means outlier distance, outlier detection, or you can also say it as a fraud detection, right? So in order to identify these things, we'll be using this Mahalanobis distance measure. Okay, next, Jaccard distance. This Jaccard distance will be used in between the different sets. Okay, so here it will be applied on sets or a binary, Okay, so here the distance formula is A intersection B by A union B. So mod, we need to apply mod for everything. Okay, so this is a formula to find out the distance, Jaccard distance, and the applications where we are going to use this one is recommendation systems. So in our previous session we have seen about this recommendation system. That means whenever we are using any online platforms, So some kind of products will be recommended. If you go to the YouTube also, some similar kind of YouTube videos will be recommended for you, right? So that in that particular recommendation system will be using this kind of measure called Jaccard distance measure. Next, Jaccard distance. Canberra distance. Canberra distance, and this measure usually it will be used to find the similarity between the objects. So here the formula is distance is equal to xi minus yi by xi plus yi. So this is a formula. It will be used to find the similarity. So that is a Canberra distance. Okay, mainly this will be used in a sparse data sets, for the sparse data sets, right? And the last one, Bray-Curtis distance. Bray-Curtis distance, and this is also used to measure the similarity, similar to the Canberras, similar to our Canberras. And see the formula here, the distance is mod xi minus yi by mod xi plus yi. So this is a formula to find the distance measure in Bray-Curtis system. Okay, so this will be used mainly in a financial analysis, financial data. For financial data which will be used, right? So these are the common distance measures which will be used in different machine learning algorithms. So in order to find the similarity, similarly dissimilarity, recommendation products, as well as anomalies. Okay, all these things we have discussed in our previous session, what kind of similarity we can find, right? So I'll write once again all the distance measures, so which we have learned so far. So the first one is a Euclidean distance, Manhattan distance, Minkowski distance, Chebyshev distance, cosine distance, Mahalanobis distance, Hamming distance, Jaccard distance, Canberra's distance, Bray-Curtis distance. So these are the distance measures so far we have seen, and for different applications. So numerical data, so this is a numerical data, this is also on numerical data, this is also on numerical data, this is also numerical, and this is on vectors, and this is again numerical, and this is a binary, and this is also on sets, and this is also a numerical, and this is a non-negative numerical. This is for non-negative numerical. So the kind of data we have to use in these distance measures, and mainly these distance measures are used to find the similarity and also recommendation systems, outlier detection, classification, clustering. So these distance measures are used to find all these things, right? So hope you understood about the complete distance measures. So these are the very common distance measures which will be used in machine learning algorithms, right? So I'll stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.